Hello, students. So, in this lecture, we are going to talk about cryptography using the modular arithmetic technique that we just learned in the previous lecture. Uh, we can do coding and decoding in many different ways. Like, if I want to send any secret message to my friend or any person, I may use any of the strategies. For example, I may take a strategy in which we discuss with one another that we'll rename or we will code every alphabet with a different alphabet. For example, we'll code A as T, we'll code B to be H, C to be E, and so on up to Z to be S. So in this way, we'll write any sentence like, for example, if I wanted to send uh, a text that read, "Your lecture is so boring," so that message would get converted into some other sort of text, and once that text gets to my friend, he would simply decode it. So this is a very simple and like less interesting way. Uh, Even kids can do that. Similarly, we can have any other coding scheme in which we replace every alphabet with a simple sort of symbols or shapes. Like in the uh, table below, it has like A with a rectangle, B with a circle, C with a polygon, and so on. So we can write any sort of message and send it to our friend, and similarly the friend has this sort of key and he would decode the message and read it. Now, what's wrong with such type of codes? Why don't we use them more often, or why can't we trust them? The reason is simple: because they can easily get decoded. Once someone gets multiple messages from both of the sides, they can simply spot out the pattern and can easily decode the messages that we have recorded or that we have sent to one another. So, what could be a possible other alternative or another way in which we can do like sophisticated kind of codings which people cannot hack or people cannot decode? So, one such type of coding is public key cryptography. They say that such type of cryptography idea has been taken from the idea of some guy which is popular in history as Carson City Kid. This kid is said to be master at perfect shuffle. Now, perfect shuffle is a kind of shuffling in the card deck in which the person takes the deck of 52 cards and divides it evenly in two parts, in exact two parts, and then he takes one card from one part and the other card from the second part and mixes all those cards in that way. So this guy has been said to have been very fast at shuffling. His hands were faster than the eye of people. So he could do the perfect shuffle fastly. Now, once the 52 cards are shuffled perfectly, that randomness or that changed deck of 52 cards would get to its exact shape, to its exact format after 52 such shufflings. It means once someone did the perfect shuffle, we would need to do 51 more shuffles and then get into the original form of that deck. So this guy later on went to secret message base where he joined, and he told the people that when you want to send a code to your partner or to other fellows, you would simply write the whole message on the deck of 52 cards. You will write one word on each card, and once you did that, you will do five shuffles of that 52 cards. So as soon as that message was delivered, this guy took that deck of 52 cards, and he knew that the 5 shuffles have already been done, so I need to do 47 more shuffles in order to decode the message. So this way he sort of provided his services to both the parties in order to code and decode the messages. But obviously we cannot do this technique, and this is again easily spottable, and people would understand that. Later in 1977, three guys, Ronald Rivest, Eddie Shamir, and Leonard Adleman, I'm sorry if I don't pronounce names correctly, they came up with a similar idea, which later they named as RSA coding scheme, in which this same shuffling strategy was used. They proposed an algorithm in which they sort of declared two public keys or two numbers which were public and everyone could know them, and they kept one number as a secret, and with the help of these three numbers they could send or receive, they could code and decode the information or numbers. Now the strategy of their coding is like this, that if someone wants to send a message, a coded number to their friend or partner, say for example they want to send a number that is W, or a digit or a message, say it is W, and remember we said that, for example, we have, not for example, the strategy is that they announced two public keys and kept one key to be private. For example, now in this case which we are discussing, we'll use two public numbers, which is one would be 7 and the other would be 143. This is for the convenience of my calculations because I have done those calculations following the book. And they kept one number private. In our case, we'll be using the private number to be 103. So the strategy is like this in the upcoming slide. It is like if I or somebody wanted to send the code, wanted to send a letter W towards any other person, he would simply raise that number to the 7th power. And once he took the number to the 7th power, he'll calculate the mode of that answer with 143. Like he will calculate the remainder of this W power 7 number when that W power 7 is divided by 143. Now the remainder would be any number which we name here to be C, and C is the coded version of W. So the simple strategy is like this. We take any number W. Now W can be 1, 2, 3, 5, 8, 100, whatever, any number. So whatever number we took, we simply raise that number to the 7th power. Again, we got any number. Now we divide this number by 143, and once we divide this whole thing, like the obtained number with 143, we definitely can get a remainder. Now we call this remainder to be C, and we say that this C is the coded version of the number which we secretly wanted to send to our fellow. So C is the coded version of W. Once our fellow receives C, he knows the other secret number which we have not told anybody. Our secret number was 143 if you go a bit back in the video. So he'll simply raise C to 103 power and will divide it by 143 and calculate the remainder, which is D. What he will do, he got C, the number which we sent as a code. He'll simply raise C to 103 power and will divide this whole answer with 143. He'll get some remainder, and we name that remainder to be D. That is the decoded message. Now, no matter what happens, this D would always be equal to W, which was the original number that we wanted to send him secretly. So this way, we sort of took a number W, we coded that number to be C, and then sent it to the guy. We took W, coded it in the form of C, sent it to the person. He decoded it in the form of D, and D proves to be equal to W. Let's play the same thing with like the help of certain numbers. For example, we want to send a number that is 71 to our friend. So we have two public numbers, that is 7 and 143. So 7 is the encoding power, where we will simply raise 71 to power 7. So 7 is the encoding power and 143 is the mode number, right? We would calculate the mode of all the numbers with the help of 143. We'll be dividing every number by 143 later. So two public numbers are 7 and 143 that we can tell to every person, and we may tell them the procedure as well, that we are raising our secret number to 7 power and then calculating its mode with 143. But we have a secret number that is 103 in this example particularly. So this is the secret number, which is the decoding power. So when the receiver would receive my secret number or my coded message, he will raise that message to 103 power and then would calculate its mode again. So we are not going to tell this 103 number to any person. Now we want to send 71, but we would not send it as 71. We'll code it into another number. So we'll calculate the 71 power 7. Remember, power 7 is the encoding power, which is a public number. We tell it to everybody. So we'll calculate 71 power 7, which will be a very big number, but we'll calculate the mode of that big number with 143. Like we'll calculate the remainder of this big number when it is divided by 143. So we'll do that 71 power 7 is a big number. Divide this big number with 143, and whatever remainder you got, write that remainder. So we get remainder to be equal to 124. You can verify these results, don't trust me. So when we raise 71 to 7th power and calculate its modulo under 143, our answer gets 124. Now 124 is the coded version of 71. We'll not send 71 to our friend, rather we'll send 124 to our friend. Now our friend got the message 124. He does not know that what does it mean, but we have given him the secret key 103. He knows this. He knows the procedure, that once he received the coded version, he will simply raise that coded number to power 103. So as soon as he receives 123, he will calculate the 124 power 103. And after calculating this big number, like 124 power 103, this would be a very, very, very big number. He will simply divide it by 143 and calculate the remainder. And interestingly, this remainder would prove to be 71. So when you calculate 124 power 103 and calculate its mode under 143, you will always get 71. And yes, remember, we simply started that we wanted to send him the number that is 71. So he successfully got 71, or he successfully received our message. I must tell you that the number 124 power 103 would be a very, very big number, such as listed here. But once you calculate the remainder by dividing this whole number with 143, the remainder would be simply 71. So if we sum it up, the procedure is like this. We get or announce any two public numbers. In our case, we took 7 and 143 to be our public codes. So we publicly announced 7 and 143 that we are using these two numbers in our coding and decoding. And we saved 103 to be the secret number, which only the receiver and sender knows. Nobody else knows this number. Now, if we want to send 71 to our friend, we'll simply calculate 71 power 7 and its mode under 143. In case remainder, when 71 power 7 is divided by 143. And that remainder is 124. So we'll send 124 to the receiver. The receiver will simply receive 124. Now he knows the secret number 103. He'll compute 124 raised to power 103 mod 143. Like he'll compute 124 to the power 103 and will divide this whole number with 143 and calculate the remainder. And that remainder would always be 71. So he received the message that is 71. Now, how does this procedure got invented? Where does these number like 7, 143, 103, and all these numbers come from? On this, we'll be like recording a new tutorial where you would see the procedure that what things work on the background of this, what makes it so simple and what makes it so easily understandable.